Hey guys, so we're going to jump into concentrations and how to calculate concentrations. Now there's one way that we can do it, there's many ways, but one way we're going to look at is calculating concentrations of solutes dissolved in solvents by using parts. And all a part really means is just a particular unit that you choose. So for example, in my family, we have a recipe for making syrup where we would take 2 parts of sugar and dissolve it in 1 part of water. And so the parts is just whatever unit we want to make it. If we want to make a whole bunch of syrup, then maybe we would take 2 liters of syrup to 1 liter of water. In our case, we use 2 cups of sugar to 1 cup of water, and that seems to work out pretty good for a particular breakfast that we may want to have or whatever. But all the parts means is just whatever unit that you're choosing. When we're talking about parts per million, then all that means is that I have a certain number of parts in a million parts of a particular solute dissolved in a solvent. So my solute would be up here on the top, 10 parts dissolved in my solvent, say water, a million parts of water. And so if I had 10 parts in a million parts, all that means is I could say, okay, well that could mean I have 10 milliliters dissolved in a million milliliters, or it could mean I have 10 liters dissolved in a million liters. Either way, all of these are going to equal 10 parts per million. You just have to make sure that the units on the top and the bottom are the same. We can also express concentrations in units of parts per billion. All that means is that instead of on the bottom having a million, now we have a billion. That's a concentration that's going to be a little bit less than parts per million, simply because I have 10 milliliters dissolved in not a million milliliters anymore, but a billion milliliters. So dissolved in a larger volume means it's going to be a less concentrated solution. So then moving on to parts per trillion, again, that would be even a less concentrated solution than something with parts per billion. Now that's assuming that all of these would be 10. 10 parts per million is going to be the most highly concentrated. Then the next most concentrated would be 10 parts per billion. And then the lowest concentrated solution would be the 10 parts per trillion. This is kind of a tricky concept because if you don't understand that in this explanation, then oftentimes what kids will do is they'll say, oh, a question will say, okay, what's the highest concentration? And kids will say, okay, well, trillion's the biggest number, so I'm going with 10 parts per trillion. When in fact that's the lowest concentration because we're dissolving that 10 in a trillion parts, not just a million parts, which is going to make it more concentrated. So that's what you need to know, guys, as it relates to parts per million, parts per billion, and parts per trillion. And questions will be as simple as and no more complicated than something like this, where you have, say, a concentration of 10 parts per million, and you have 10 liters of a substance that's being dissolved. How much is that need to be dissolved in order for you to achieve this concentration of 10 parts per million? And you would just say, well, it's parts per million, so it's going to be a million. And because this is liters, this has to be liters.